This conference will now be recorded.
Okay. So I'm going to close this project. So I will quickly brush up the PWM with the help of bit banging method. So this is the code which has been provided to you in the templates. So first, coming to the header files, you will have two header files. One is main.h, which has the macros defined for LED1 as for RD0 as LED1, for port D as LED array1, and for tris D as LED array1 DDR. So on representing 1 and off is representing 0. Then digital keypad.h, as you already know, it has the macros for the switches and the functions prototypes for read digital keypad and init digital keypad function. Now coming to the source files, what we are trying to do here is whenever I press switch 1, the duty cycle has to be increased, and I press switch 2, the duty cycle has to be decreased. So whatever logic we wrote, we have followed the same being written here also. So first I'm going to read the key from the digital keypad as the level detection, because as long as I keep the switch pressed, I have to keep increasing the duty cycle, and if switch 2 is pressed, I have to keep decreasing the duty cycle. Now after I read the key is being passed as an argument to the software PWM function. So according to the bit banging method we wrote, it was actually the complete logic, we had it written here itself, but this time we are having it written in a separate function. The period is taken as 100. The duty cycle is treated as 50. Initially, duty cycle is 50. Then a character variable called loop counter is taken, and then a variable called wait is taken just to introduce a non-blocking delay. Now, not of wait minus minus is to just increase the delay. So just to provide a delay, because if I press the switch for, let's say, 1 second, so within a fraction of second, I can reach the duty cycle from 0 to 100. So I don't want that to rapidly increase from 0 to 100. It has to gradually increase. So we took a wait, which is in fact a non-blocking delay. Now wait is assigned with 500. If key is equal to switch 1 and duty cycle is not equal to period, we are going to increase the duty cycle. And if key is equal to switch 2 and duty cycle is not 0, I'm going to decrease the duty cycle. Now for how much ever is the duty cycle, LED will be provided with on, and uh, if the loop counter is greater than duty cycle, LED is provided with off. So when loop counter reaches period, loop counter will be assigned with the value 0. And in our logic, we wrote loop counter plus plus here itself, but here we have got it written in a separate statement. So what I'm trying to do here in this is, as long as the duty cycle is provided, LED will be kept on, and for the duty cycle, like for the rest of the period, the LED will be kept off. And we make the switching between LED as 1 and LED as 0 in a very faster rate, that your microcontroller or your LED will feel as if there is a continuous voltage being provided. So because of that, the LED will be glowing with 50% duty cycle initially. I mean 50% brightness initially. So as you press the switch 1, the duty cycle is going to increase, the brightness is going to increase in turn. And if you press switch 2, duty cycle decreases, the brightness also gets decreases in turn. Is that clear? Okay. So that was a doubt, like it was a request from Medha. I hope Medha, you got the logic. Okay. So proceeding next, we were discussing things with respect to the SSD in the previous class. So we finished the SSD's basic understanding in the previous class. So SSD is nothing but 7-segment display. So we are going to have a 7-segment display taken. In fact, each of the display has 8 segments, but the very commonly used is the 7 segments. So we call it as a 7-segment display. In short, SSD. Now each segment of the SSD is going to have an individual LED provided to it, and in order to glow that particular LED to the segment, you have to either provide a 0 or you have to be providing a 1. Now that completely depends on whether you have a common anode configuration or common cathode configuration. Now, in our case, we got to know what we have is a common cathode configuration. So you are going to have all the cathodes connected to ground in common via the transistor, which acts as a switch. So we have corresponding segments which are being connected to the port D pins. So RD0 to RD7 will be used for segment A to segment DP, and we will have the control lines connected from RA2 to RA5. So yesterday we finished the discussion of that SSD, and we also made a table here. So what needs to be provided to the port D whenever I have to get that display on a particular SSD, we have it written. We also spoke and made a decision about the direction of the pins of the port. So RD0 to RD7 has to be treated as output because they are connected to LEDs in turn. And RA2 to RA5 should also be treated as output because they are serving as an input to the transistor. So with respect to the microcontroller, it will be treated as output. Now let us do one small project. So the project here which we are supposed to do is, I want to display 1, 2, 3, 4 on 4 different SSDs. So if you observe in our board, okay, on our board, I'm sorry. So on our board, we have got 4, let's say SSDs here. So in these 4 SSDs, I want different value to be printed. I want 1, 2, 3, and 4 to be displayed on the 4 SSDs. Okay. So now let us see how to have these data displayed on the SSD. Now basically, first and the foremost thing, I will start creating the project directly. So I'm going to start creating the project, creating a new project. Okay. So here, I'm sorry. So I'm going to file and create a new project. So the same procedure I'm going to follow. Now let me keep the name of the SSD as, one second. So family, it has to be mid-range 8-bit MCUs. The microcontroller has to be PIC16 EF877A. And I'm skipping the tool, clicking on next, selecting the cross compiler. The project name, I'll keep it as SSD. Okay. And I'm going to click on finish. Okay. Now SSD's initialization has to be done. First, I'll go to the source files. I'm going to add main.c file. So I'm going to new and click on main.c. The file name is main. The extension is .c. Okay. Now being in the main.c function, I have to do the initialization of the SSD. Okay. So basically, we have to do the initialization of the SSD. For that, I'm going to have a separate function called, and the name of the function is init SSD. Okay. So I have to do the initialization of the SSD. So that I'm going to have it written in a separate .c file. So I will go to source files, create a new C source file. The name of the function, the name of the file has to be SSD. The extension is .c. Okay. So I'm trying to create a project. where I will be able to display 1, 2, 3, 4 on the 4 SSDs. So now coming to the ssd.c file, here I'm supposed to write the definition of init ssd function. So function is not taking anything as an input, function is not returning anything as an output. Now here, what should be the basic initialization to be done? The first initialization is I have to treat RD0 to RD7 as output. So I have to set RD0 to RD7 as output. Can you tell me how to do it? How to set RD0 to RD7 as output? Come on. How to set RD0 to RD7 as output? Yes. So I have to write trisd with the value 0x00. Okay. So trisd has to be written with the value 0x00. Next, I have to write RA2 to RA5 also as output. How to do it? I want to set RA2 to RA5 as output. So is it right if I write tris A is equal to 0x00? Will that be right if I write tris A is equal to 0x00? In that case, you are actually making all the pins of port A as output, not just RA2 to RA5. I want only RA2 to RA5 to be made as output. Okay, so assume tris A has already something like this. So XXXX. I want only RA2 to RA5 to be made as output. So something like this. Okay. So RA2 to RA5 will be XX 0000 2, 3, 4, 5. Okay, XX. Now tell me how to achieve this. This is what I have in tris A. This is what I want to end up getting. I just have to make RA2 to RA5 as output. How will I be able to do it? Okay, so and with 0, what should I be ANDing with? Yes, so if you take binary, I have to AND with 11000011. Now what is the hexadecimal equivalent of this? 0x 1100 is C and the 0011 is 3. So if I end up writing like this, tris A is equal to tris A, okay, tris A and with 0xC3. So that is how I'm making only RA2 to RA5 to be treated as output. Is that right? Okay. Now, after this, I have to display something on the SSD. Okay. So I have to display something on the SSD after I do the initialization. I want to display 1 on SSD1. I want to display 2 on SSD2, 3 on SSD3, 4 on SSD4. Now tell me to display 1 on SSD0. Okay. Or let's say 1 on the first SSD. This is the first SSD. So what should I write? To display 1 on the first SSD. So I would say display 1 on first SSD. Can you tell me what should I do to display 1 on first SSD? So whatever data I want to display, where should I be providing it? Whatever data I want to display, where should I be providing with? Where are the segments A to DP connected? In the circuit on board, where is it connected? Yes, it is connected to port D. So if I have to display 1 on a particular SSD, what should I write port D with? So yesterday we made a table if you remember. So whenever I had to display 1, I found a hexadecimal equivalent to be given to port D. So do you remember what is that hexadecimal equivalent? 0x06. Okay, so let me show that again. So it is, you can see, for 1 it is 0x06. So I have to write port D with 0x06. Okay, next, after I write the data to the port D, how to turn on that particular SSD? Look at the circuit on board and decide how to turn on that particular SSD. I want the first SSD to be glown now. So which pin should I take now? Which is the control line for the first SSD? It is RA2. Okay, it is RA2. It is not RA0. It is RA2, RA3, RA4 and RA5. So what should I write to the RA2? I have to be providing ground via that. So RA2 has to be returned with 1. Now similarly, to display 2 on the SSD2. Okay, so display 2 on SSD2. Okay, so what should I provide to the port D? Port D should be given with 0x5b, if I'm not wrong. See, for 2 we wrote 0x5b, right? Okay, so I'm going to have 0x5b return, and I have to turn on that corresponding SSD by writing RA3 return with the value 1. So I'm going to copy the same statements for the rest of the 4 SSDs. Okay, so this is to display 3 on third SSD. Okay, and this has to display 4 on fourth SSD. Fourth SSD. So what should I write to port D to display 3? So display 3, it is 0x4f. Okay, so this has to be written with 0x4f. And I have to write RA4 with the value 1. Then to display 4, it is 0x66. So here 0x66 and it has to be RA4. Sorry, RA5. Right? So I want to display 1 on first SSD. So I wrote port D is equal to 0x06 and RA2 is equal to 1. Then display 2 on second SSD, display 3 on third SSD, display 4 on fourth SSD. So that is it. We are done. Let us execute this and check the output. Okay, so I'm going to build this. Build is a failure. What is the problem? Okay, so I'm using, yes, so there's a problem. First and the foremost thing, I'm calling init SSD function. Its prototype is written in some other file. So I'm going to create a header file, first and the foremost thing. So here I create 2 header files. One is main.h, new header file, header file. So that is main.h, and one more is ssd.h. Okay, and one more is new C header file, that is ssd.h. Okay, now what will I do in main.h? I think I didn't need a main.h, but anyways. So in main.h, I'm going to define the built-in header file as include, let's say, the xc.h. Okay, then I will also include the ssd.h here itself as include, let's say, It's a user defined, so ssd.h. Now here in the main file, I will include main.h. So all of this you should be used to it. Okay, main.h. And in your ssd.c also, I will include the main.h file. So include main.h. Then in the ssd.h, I will write the prototype of the header file. So without header file, like to use this trsd, okay, to use this trsd and all, I need xsc.h header. That xsc.h header I have written in main.h file. So that is why I had to add it. Else I will get an error here. You can see in the ssd.c file, there is an error that you are trying to use an undeclared identifier called trsd. So that will be an error. In the ssd.h file, I will declare the function init ssd. Okay, so init ssd, then void as the return type. Okay, yes. So now things are fine. Let me save and let me build. Are you people able to follow this? Okay. Please let me know if you're not getting any point. So I'm assuming these things are familiar to you right now. Okay. So this time you can see build is been successful and loading is also completed. So let me load the hex file now. I'm going to file, then load hex. So I created a project by the name SSD. So there distribute, default, production, the hex file. So if you see, okay, so I have to use port D this time. Okay, I have to use port D this time. So if I have to use port D, then the DIP here should be against port D. Okay, so if you observe the DIP here, it should be against port D. Okay, now let me switch that DIP towards LED 1. Are you able to see 1, 2, 3, 4 here? Are you seeing 1, 2, 3, 4 here? No. Yes? Are you literally seeing 1, 2, 3, 4 here? No. So that is because the switching between RA2, RA3, RA4 and RA5 is literally happening on a very faster rate. Okay. It is in fact happening on a very faster rate. So you have to induce delay every time, a small delay every time before you try switching. Okay, you have to induce a small delay. So for that, I take an integer variable called I. So I will write a blocking delay itself here. Okay, so for I is equal to 0, let's say I is equal to 500 and I minus minus. Okay, so this I'm going to write it everywhere. So after every switching, I'm going to have it written here. Okay, now let me build. Okay, so file, reload last. That is still not happening. 1 second, let me increase the delay. Okay, there's one more thing. There is actually a problem. So initially what I have to do is, in fact, not just setting the direction, I also have to turn off all 8 SSDs, isn't it? So I have to turn off all 8 SSDs. I mean all 4 SSDs. So how to turn off all 4 SSDs is, I have to write RA2 to RA5 as what? I have to write RA2 to RA5 with 0, correct. So RA2 has to be written with 0, RA3 has to be written with 0, RA4 has to be written with 0, and RA5 should also be written with 0. So initially I have to turn off all 8 SSDs. And also one more problem here is, after I turn on first SSD, okay, after I turn on first SSD, for the second time I'm turning on the second SSD. What about the first SSD? What about the first SSD? Is it on or is it off? So it should go to 0, isn't it? It has to be turned off. It is on right now, I have to turn it off. Okay, so here when I make RA2 as 1, the rest of the 3 has to be turned off. So I'm going to write it like this, RA2. I think I'll copy this. Okay, so this one. Okay, so RA3 has to be written with 1. Then here RA4 has to be written with 1. And here RA5 has to be written with 1. Okay, and here RA2 has to be written with 1. Are you able to get this? So I wanted to write something to port first SSD. I wrote it to the port A and I turned on first SSD. All the 3 other SSDs are turned off. So let me give you a delay of 500 itself. Okay. So here also I'll give 500. So whatever I want to display, I'm giving it to port D. Then I'm turning on the second SSD. All other SSDs are turned off. Then whatever I want to display, I'm giving it to port D and I'm turning on the third SSD. All other SSDs are turned off. Similarly, whatever I want to display, I'm giving it to port D. I'm turning on fourth SSD. So this should be returned with delay of 500. So now let me build this. Okay, so build is happening. Let me just wait till the build gets completed. Okay, build is successful and loading is also completed. Can you now see 1, 2, 3, 4 being displayed on the SSD? A small delay in fact is really required. Okay, so between the switching, so if you don't write the delay, the switching happens on a very faster rate, that the brightness of the SSD will be decreased. Even now if you see, the brightness of the SSD is in fact decreased itself because switching is happening on a very faster rate. A small delay to be provided is necessary to glow that LED with 100% brightness. Okay. Now actually, whatever I performed here, uh, can can we just write 0, 0 AX after loop instead making 0 all? Sorry, I didn't get, Babu. Can you please repeat? Can we just write 0 for 0 X other things after loop instead making? See, you cannot write it for only once. Okay, all of this you cannot write it for only once. The corresponding SSD has to be turned on. All other SSDs have to be turned off. Okay, So in this case, what I can do is, when I initialize RA2 to 1, okay, in the second time, I can just write RA3 with 1 and RA2 with the value of, let's say, 0. Okay, so I have to do something like that. But for the next time, if I write RA2 with 1, the previous RA will be returned with 1 also. So whenever I'm going to turn on a particular SSD, rest of the SSDs have to be returned with the value 0. Now if you observe, am I not repeating the same things again and again? Am I not repeating the same logic again and again? So don't you think I can do a function call instead of me having things returned like this again and again? Yes. So what I'll do is, observe, I'll take a array called SSD. Okay, I'll take a character array called SSD, let's say of size 4, because I want 4 SSD. Now I will write SSD of 0 with whatever I want to display on SSD 1. So that is 0x, let's say 0x, I want to display 1, so 0x06. Then on SSD 1, I want to display 2, so that will be 0x5b. On SSD 2, okay, I want to display let's say 3, so 0x4f, okay, then 0x66. SSD of 4, I'm going to pass 0x66. Okay, now I'm going to call, okay, this is SSD of actually 3. Okay, so after this, I declared a character array called SSD of size 4. So SSD of 0, unexpected end of file. See, I took an array here. So SSD's name, I'm keeping it as SSD of 0, SSD of 1, SSD of 2, SSD of 3. Okay. So why is it giving me up error? Okay, anyways, let's continue. So after this, the next thing is, I'm going to call a function called SSD display by passing SSD as an argument. Okay, I'm calling a function called SSD display by passing SSD as an argument. So after this, I'm going to write the definition of that function in this ssd.c. So return type is void. Function's name is SSD display, and this is collecting a character pointer called data. So just assume a character pointer called data. So let me have the prototype added to the ssd.h file here. Okay. Now coming to the ssd.c file, I have 4 SSDs. So I will run a loop for 4 times. For let's say character j is equal to 0, j lesser than 4 and j plus plus. Okay. Now what should I do here is, the port D, okay, the port D has to be provided with what? It has to be provided with data of 0. Sorry, data of j, correct? Port D has to be provided with data of j. So this is a data array. Data array is collecting all of these macros. So what and all macros it has collected is 0x06, then it has collected 0x4, 0x5b, then it has collected 0x4f, Then it also has collected 0x66. Now first I have to pass port D with data of 0. So that is 0x06. Then I have to write RA2 as let's say 1. I have to write only RA2 as 1. So tell me how to write RA2 as 1 with the help of port A. How to write RA2 as 1 with the help of port A. So port A is equal to, how to write RA2 as 1 with the help of port A? Can I do 1 left shifted for 2 times, right? So 1 left shifted for 2 times as of now. So 1 left shifted for 2 times if I do, then if I assign it to port A, then I am going to have port A return with, sorry, RA2 return with 1. Okay. Next, RA3 has to be returned with 1. What should I do? Just observe, I'll write it with J here. Correct? Do you think this will work? So first port D will be assigned with 0x06. Then port A will be assigned with 1 left shifted for 2 times. So 0, 0, 0, 0, 0, 1, 0, 0. Okay. Then port D will be assigned with 0x5b. Okay. So 0x5b, and port A will be assigned with 0, 0, 0, 0, 1 left shifted for 3 times. So 1, 0, 0, 0. Isn't it? I'm directly assigning. So I'm not performing any operation. I'm directly assigning this. So if you want, you can use logical operator also. I mean 1 bitwise operators also. Then port D gets assigned with 0x4EF, and port A gets assigned with 0001, 0000. Then port D gets assigned with, okay, then port D gets assigned with 0x66. Then port A gets assigned with 0010, 0000. Are you able to follow this? Okay. So let me save this. Let me build and see if this is going to work fine. Okay, some errors. So this is just a warning. Okay, void main. I have missed the parenthesis. Okay. So now let me build. Okay, loading is completed. I'm doing reload last. Okay, so if you can see, I'm getting the data displayed, but not exactly according to my requirement, because I skipped writing the delay here. So after I load, I told you, you will not be able to observe the output properly. So there is a small delay required. So I'll take for, let's say int k is equal to, I'll keep 500, k minus minus terminated with a semicolon. Okay. So I'm keeping blocking delay because when I call the SSD function, its operation should only be to display something. I'm not going to perform anything else. Okay. So that is why I took a blocking delay in this scenario only. So I'm going to file, do the reload last. So can you now see 1, 2, 3, 4 being displayed? Okay. So in fact, you have the same in the templates also. So let me close this. Whatever I tried writing, you have it written in the template also. So I just wanted to show how coding happens, which is why I tried writing it from the scratch. So let me open you the template and show you how that is working. So under SSD, we have SSD drive. So I have one file ssd.h and two source files. One is main.c and ssd.c. Now coming to the main.c, you can see there is an init SSD function called being done. Coming to the init SSD function, data port DDR is nothing but tris_d, which is returned with the value 0x00. Then SSD control port DDR is port A. Okay, so that is port A, and that you are trying to write with port, sorry, this is not port A, it's data direction registered. So it's tris A, return with tris A and with 0x03. Okay. Then I want to turn off all all 4 SSDs. So I had to write RA2 to RA5 with the value 0. So instead of having it individually returned, we are trying to write port A is equal to port A and with 0x03. So whatever is returned to RA0 and RA1, we are retaining it as it is. RA2 to RA5, we are having it returned with the value 0. Then we have some macros taken. You can observe. For 0, it is 0x3f. For 1, it is 0x06. For 2, it is 0x5b. For 3, it is 0x4f. So up to 9, we have taken the macro. So to go with the main function, there is a character array called SSD return of size maximum SSD count. So maximum SSD count is 4. So there is a character array called SSD of size 4. So SSD of 0 is returned with macro 1, which is nothing but 0x06. SSD of 1 is returned with macro 2, then macro 3, then macro 4. That is passed as an argument to the display function. So display function is collecting it as a pointer. The loop is running for 4 times. SSD data port, that is port D, is written with data of digit. Then SSD control is nothing but SSD control port and with 0x03. So first actually I'm turning off all 4 SSDs. Then I am ORing it with 4 left shifted for digit number of times. Okay, so 4 left shifted for digit number of times. And this small delay is to observe the output on the SSD. So whatever logic we wrote, it's been the same. Okay, so that is the program here. Let me build this and show you the output. This output will also be exactly similar to that. You can see file. I'll go to, let's say, load hex. Okay, so I'm going to load hex here. Let me load the hex file and show you the output. So here under template, I'm going with SSD sources, SSD driver, distribute, default, production, the hex file. So I can see the same is being displayed. Is it clear? Okay. So we'll do one more classwork on SSD. Before that, you can take a break of 2 minutes. Okay, can we continue? Okay, fine. Let us continue with another classwork. So the next classwork I want to do is, we will try implementing an up counter. So up counter in the sense, initially your SSD has to display 0000. Then it has to display 0001. So then it has to display 0002. So that way it has to reach till 9999. Then it has to roll over to 0. Okay, this is the project's main idea. I have to display 0000 till 9999. I have to increment the count, and whatever incrementation of count is seen, I have to display it on the SSD. And once the value reaches to a maximum of 9999, we have to overflow that to 0. Now let me take the same project. I'm going to create a new project, and the name of the project is SSD up counter. Okay, so I'm going to create a project. So I'm going to file, then new project. So after I click standalone, I have to select the family. So the family is mid-range 8-bit MCU. The name of the microcontroller is C15 877A. Then I'm going to click on next. Click on the cross compiler. The name of the project I give is, let's say, SSD up counter. Okay. Then click on finish. So after I create the project, I will actually copy the project from another file. Okay. So I will copy it from a driver. So let me open a driver and copy the files from that driver. Okay. So from SSD driver, first I'll copy the header file, that is ssd.h. I copy. I paste it under the header of my project, that is SSD up counter. Then I copy the source files, both main.c and ssd.c. I copy it, and I'm going to paste it under source files of up counter. After that, I'll close the project. Now I will make changes only to the main function. Okay, so we will make changes to the main function. Now, what are those changes is, first and the foremost thing, I'll open the main.c file. Here, let me first implement the logic of up counting. Okay, I have to implement the logic of up counting. Now tell me how to write the logic of up counting. What do I need to achieve it? I will take an integer variable called count, return with the value 0. Can you help me implement up counting? If, okay, I don't need a loop. I am already inside while of 1. So if count is lesser than 9999, I'm going to increment the count. Correct? Count plus plus. Else, okay, else if count is equal to 9999, what should I write to the count? Count is equal to 9999. What should I write to the count? Yes, I have to write it with the value 0. Now, don't you think this increment happens on a very fast rate because I am inside the while of 1? This will happen on a very fast rate. So for that, I need a small delay to be provided. Okay. So for that delay, I will take the integer variable called wait, return with the value, let's say 300. Now, if weight minus minus is equal to, let's say, 0. Okay. So, I'm going to perform this operation. And here, I'm supposed to write weight with the value, let's say, 300 back. Are you able to follow this? So if weight minus minus is equal to 0, I'm checking if count is lesser than 9999, I'm incrementing the count. When count reaches 9999, I'm going to say count is equal to 0. Now assume whatever is the count, I have to display it on the SSD. Okay, whatever is the count, I have to display it on the SSD. So I have to update my SSD array. Assume the count I have is 4579. Okay, so count I have is 4579. What should I be displaying on SSD of 0? What should I be displaying on SSD of 0? I have to display 4. On SSD of 1, I have to display 5. On SSD of 2, I have to display 7. On SSD of 3, I have to display 9. Tell me how to get 4 from the count. Count is 4579. How to get 4 from the count? Divided by what? Count divided by what? 1000, right? Then how to get 5 out of 4579? How to get 5 out of 4579? Will I get it if I do count divided by 100? Will I get it if I do count divided by 100? No, I will get 45. When I do count divided by 100, I will get 45. Tell me how to get 5 out of 45. How to get 5 out of 45? Come on. If I do count divided by 100, I will get 45. How to get 5 out of 45? Yes, I have to mod by 10. Okay. Next, how to get 7 out of 4579? It has to be count divided by 10, also mod by 10. Then how to get 9 from the count? I can just do count mod by 10. Correct? Now tell me, if I want to display 4 on the SSD, so SSD of 0 is assigned with 4. Do you think providing 4 to the port D will display 4 on the SSD? Do you think providing 4 to the port D will display 4 on the SSD? No. So if I have to get 4 displayed on the SSD, what should I give to the SSD? If I want to be displaying 4 on the SSD, what should I be providing? It is macro 4, which represents 0x66, isn't it? To get 4 on the SSD displayed, I have to provide the macro 4, which represents 0x66. Now, how to provide that macro to the SSD? Instead of the values directly, how to provide the macros to the SSD? Now, observe how I will be doing. I don't need another function. I take a character array called, let's say, digit of size 10, and I'm going to have it initialized with all macros starting from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm having it displayed with I'm having a digit macro taken, digit array taken. I'm assigning it with 0, 1, 2, 3, 4, all macros. Okay, so now what I will do is I will write digit of count divided by 1000. So this is digit of uh, count divided by 1000 mod by 10. This is digit of count divided by 10 mod by 10, and this is digit of count divided by 10. So now what happens is, when I do count divided by 1000, I will get 4. What is digit of 4? Digit of 4 is representing macro 4. So SSD of 0 gets assigned with macro 4. Similarly, digit of count divided by 100 mod by 10 will give me digit of 5. So digit of 5 represents macro 5. Macro of 5 gets assigned to SSD of 1. Then macro of 7 gets assigned to SSD of 2. Macro of 9 gets assigned to SSD of 3. That macros gets passed as an argument to the display function. So port D here gets assigned with the macros value. The corresponding SSD will be turned on and you are providing a delay. So that's the only change. You can observe, I'm going to build this project. So common error, because I copied the file from another project, I will get linker issues. So let me solve this. I have to click on project settings. Okay. Then I have to click on apply, then click on OK. So after OK gets enabled, you have to click on OK as well. After this, you have to rebuild the project. Okay, you have to build the project again. So I'll go here and give build project again. Okay, so I'll get some warnings because of bitwise operators being used, but no issues with that. Okay, so now build is successful and loading is completed. Let me load the hex file. Load hex. So I'll go with this. There is SSD up counter, distribute, default, production, the hex file. So initially it starts with 0000, then 0001, then after some time 0002. In fact, the weight I have taken is pretty large. So whatever I've kept 300 is being large. Let me keep it 200 to show the output a little faster. Okay. So I'm going to build this project again. So like this, it is going to make an overflow after it reaches 9999. So I've reduced the delay, build is happening. Let me do reload last now. So you can see the increment happens on a little faster rate. So from 0 to 1, then 1 to 2, 2 to 3, 3 to 4. It has to reach till 9999 and it has to overflow to 0. So this is SSD's up counter. Is that clear? Is that clear? Any doubts? Okay. So if you want, you can note this function. So like you can note the main function, the logic behind the main function. So let me just display this. If you want, you can take a snap if required. How to reduce flicker? Uh, so you have to give the proper delay. So flickering in the sense, are you not able to constantly see? So that may be because you have increased the delay. So reduce the delay, the flickering has to stop. Okay. So that was about the concept of SSD. I hope you got it. So SSD is used to have something displayed in order to achieve a good line of sight. So because SSD has a good line of sight, you can have something clearly displayed on the SSD. So generally you use SSD in order to display if you have got any error numbers, some important data to be displayed, which is visible for a longer distance. You generally make use of the SSD. So that is one of a very commonly used feedback device to have the error numbers displayed. Now associated to this SSD, I have one more small topic which I can finish it off today, which is nothing but the internal EEPROM. Okay. So we have one small topic. Let me finish that off in addition to this. So that is nothing but data storage. Okay, so we have something called as data storage. Every microcontroller, if you know, comes with its own built-in memory, and our microcontroller will also have its own built-in memory already available. Okay, so typically storage is something which is used to have something data to be stored. So it completely depends on how much data you have got to be stored and what is the amount of data you have got to store and how many times you are supposed to rewrite the data. Okay. So usually what I say is that storage completely depends on the type of data you have got to store and the amount of data you have got to store. Now assume you already know different types of memories available for any embedded systems design. Assume there is a data, a very small amount of data to be written. Okay, there is a very small amount of data to be written. If you are given with an option to choose the memory, which memory will you be choosing to have very small amount of data to be written? So I have very small amount of data to be written. So which memory do you think will I be choosing? Stack, RAM, flash memory. Okay. So generally, if you go with flash memory, you have neither either a NAND flash or a NOR flash. So NAND flash you prefer if you have very large amount of data to be written because it offers high density. And you choose NOR flash if you want more reliable data to be written. So because it offers more reliability. So generally, if there is very small amount of data to be written, the very commonly used memory is EEPROM. Okay, if the amount of data to be returned is comparatively smaller, we use a EEPROM rather than ROM or RAM, because both RAM and ROM has their own disadvantages. So very commonly used memory to have a small amount of data return is a EEPROM. So whenever you have got a huge amount of data to be written, you may go with NAND flash. If you have a code to be written, you can have it written with NOR flash. So depending on the type of the data, the amount of the data, you can choose the memory of your requirement. Now, I'm not going to choose, I'm not going to buy a particular memory, okay, because most of the microcontroller will come with its own memory. And in case of our microcontroller, the PIC16F8778 comes with a flash memory. It also comes with an internal EEPROM. Okay, so it comes with a flash memory. It comes with an internal EEPROM. Now the disadvantage of a EEPROM is you can have very small amount of data return. Okay, if it is a EEPROM, you can have very small amount of data return, because you can rewrite the data for any number of times, but there is a disadvantage associated to it. And the disadvantage is you will have more number of write cycle. I mean, to have a small amount of data written, you will need much time. Okay, so that's the disadvantage of a EEPROM. So the writing speed in case of EEPROM, over, it will take more time to have small amount of data return. But let me tell you, in our case, our microcontroller comes with a built-in flash memory. It also has a EEPROM. So let us now configure the EEPROM of our microcontroller. Okay, so we are going to have some data return in the EEPROM of our microcontroller. Now, in order to know some information regarding the EEPROM, I'm going to open the data sheet and refer it, because it is an information associated to the microcontroller. I'm taking you to the table of contents. Now look at this and tell me which section should I be referring to know of the features of EEPROM. Which section? Yes, it is section number 3, data EEPROM. Now please understand, the data EEPROM and flash program memory is readable as well as writable during the normal operations. So during normal operations, you can have the data returned to the EEPROM. You can have the data read from the EEPROM. But in order to do these operations into the EEPROM, I have to be dealing with some special function registers. We call it as SFRs, the special function registers. So these are the special function registers associated to the EEPROM. So one is EECON1, the other one is EECON2. So these two are control registers. Then we have EE data, which is a data register. EE data H, that is a EE data high register. Then EE ADR, it's an address register. This is address high register. So the EEPROM consists of 6 special registers, special function registers. 2 belongs to the control register, 2 belongs to the data register, and 2 more belongs to the address register. Now, when interfacing the data memory block, EE data holds the 8-bit data for the read or write operation. So whenever I have to write any data to the EEPROM, that data has to be returned to the EE data register. Similarly, EE ADR holds the address of the EEPROM location being accessed. So in what address I have to perform the operation, that has to be returned into the EE address register. Okay. Now, These devices has 128 or 256 bytes of data in the EEPROM with an address ranging from 0 to FFH. Okay, so the size of the EEPROM can either be 128 bytes or it can be 256 bytes. Okay, so in case of our microcontroller, the size of the EEPROM is 256 bytes. Okay, our microcontroller has a size of 256 bytes. So the address of the memory is varying from 00x to FFH, means 0x00 to 0xFF. So please understand only one simple thing. Whatever data you want to write, you have to write it into the EE data register. Whatever address you want to perform the operation, you have to write the address into the EE address register. Okay, that is the only thing I have to perform. And the addresses varies from 0x00 to 0xFFH. So that is the basics of the EEPROM. Now let us try doing a small project. The hex file will be stored in flash. Yes, as of now, whatever executable file we have got generated, the hex file, that will be available, in fact, not in the flash, because we don't have NOR flash. What we have is a data flash. It's a NAND flash. So whatever hex file we have taken will be available in the RAM. Okay. Now let us do a small classwork. I have to implement a key up counter. Okay. So what kind of data do we store in EE data? Whatever data you want to write into the memory of EEPROM, you have to write the data into the EE data register. Only then this register will have the data return into the EEPROM. In what address you want to write, I have to write it into the address register. Now let's say I have a data 0. Okay, I have, let's say, character A to be stored in, okay, to be stored in 0x56. Okay, so I want, in one address I can store only 1 byte of data. Okay, if the size of the EEPROM is 256 bytes, okay, address varies from 0x00 to 0xFF. Okay, so that means 1 byte will have one address provided. So address starts from 0x00 to 0xFF. Assume I want to write character A into the address 0x56 of the EEPROM. So whatever data I want to write, I have to write it into the EE data register. Okay, so EE data has to be written with character A. Then EE ADR register should be written with 0x56. Now if I write it like this, the program will have character A return into the address 0x56 of the EEPROM. Are you able to follow this? Okay, fine. Now let us do a small project. I want to implement a key press counter. Okay, I have to implement a key press. Can we overwrite if data is already present in 0x56? Yes, because EEPROM is the one we are using. You know that you can erase the data, you can rewrite the data for any number of times. So rewriting is allowed. Okay, I'm trying to implement a key press counter. I'm supposed to count up to 9. Okay, for after every press of switch 3. Okay, so whenever I press switch 3, I have to increment the count. Now, if I press switch 1, okay, I have to store the count to EEPROM. Store the count to EEPROM, and whenever I press switch of, let's say this is switch 2, this is switch 1. Whenever I press switch 1, I have to store the count to EEPROM. Whenever I press switch 2, I have to restore the data in EEPROM to count. Okay, so please understand what I have to do. I have to start the count with 0. Whenever I press switch 3, I have to increment the count. So if I press switch 3, count has to increment to 1. If I press switch 3 again, count has to increment to 2. If I press switch 3 again, count has to increment to 3. So that way, whenever I press the switch 3, the count has to get incremented. It has to reach a maximum of 9. And after reaching 9, it has to overflow to 0. Okay, so overflow to 0 after reaching 9. Okay, so I have to overflow to 0 after reaching 9. Now, whenever I press switch 1, this count value has to be stored into the EEPROM. Okay, whenever I press switch 1, this count has to be stored to EEPROM. Let me store it into the address 0x00, the very first address 0x00. So whenever I press switch 1, the count has to be stored to the EEPROM. When I press switch 2, whatever count is stored into the EEPROM, that has to be collected back to the variable count. Okay, that is what I want to perform. Now, whenever I have to write to the EEPROM, okay, so whatever data I have to write it into the EEPROM data. Okay, so whenever I want to write into the EEPROM, write the data to the register EE data. Okay, then you have to write the address to the EEPROM register. Okay, so whatever data I want to write, I have to write it into the EE data register. In which address I want to write, that address have to be returned into the EE address register. Similarly, whenever I want to perform read operation, when I want to read from EEPROM, okay, first specify in which address I want to read. Specify in which address read has to be done, okay, into the EEADR register. So from which address I have to read, that address has to be specified in the EEADR register. Then whatever data you want to read will be collected into the EE data register. So you can read the EE data register. Okay, you can read the EE data register. Okay, so I hope you are able to follow this. Now, instead of me writing into the EEPROM, reading from the EEPROM, instead of me involving all of this, I have a built-in function already available. Okay, I have a built-in function already available. Now, what is that built-in function, or how to know that built-in function is? You can click on the header xc.h. You can right click and you can click on navigate. Okay, first go to the xc.h header, right click, navigate, then you can click on go to declaration or definition. Okay, go to declaration or definition. Now if you scroll down, you will see a header included for pic.h. I'm repeating again. First you have to go to here xc.h. You right click on navigate, then click on go to declaration or definition. So you will get xc.h file created. From there, you scroll down, you will see the header associated to the PIC microcontroller. So again here, you right click, navigate, go to declaration and definition. So that will open your pic.h. Again scroll down. Okay. When you scroll down, you will see a header associated to EEPROM routines. Okay. There is a header called EEPROM routines. Again right click, go to navigate, go to declaration or definition. So if you scroll down here, you can see two functions prototype. One is EEPROM write function. The other one is EEPROM read function. So that's the prototype. I copy it. I paste it here. So one is EEPROM write function. The other one is EEPROM read function. So whenever you want to perform write operation to the EEPROM, you can call the function EEPROM write function. Okay, this is the function you are supposed to call. Now assume to the EEPROM, I want to write character A into the address 0x00. First, I have to specify the address. So it is 0x00. Then I have to specify the data I want to write, which is character A. Okay. So I just have to call the EEPROM write function by passing the address and the data I want to write. Similarly, if I want to perform the read operation, I just have to call EEPROM read function by specifying the address. So I call EEPROM read function by specifying the address as 0x00. What do you think this function returns me? After I call the read function, what will it return? So it returns the data which is returned in this address. I previously wrote character A into the address 0x00. So EEPROM read function should give me character A, which I can collect it into a variable called ch. So whichever variable you want, you can collect it. Are you able to follow the EEPROM read and write function? Okay. Now observe, I already have a template for this. I'm going to open that template. Template code. Then data storage. Okay, under data storage, we have internal EEPROM. Okay, now here, let me close all of this. So under header files, there's digital keypad.h and ssd.h. Okay, I'm going to display that value on the SSD. Whenever I press switch 3, count will be incremented. So that count I will display it on the SSD. So you can see the main.c file, digital keypad.c, ssd.c, there is no change in that. First to start with, here, you can see there is a variable called count taken, a SSD array of size 4, digits array of size 10, initialized with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 macro. Then I'm calling read digital keypad function by passing state as an argument. Okay. So that I'm passing to the EEPROM test function. Okay. That key, whatever I read from the digital keypad in the state detection, I'm passing it into the EEPROM test function. Now, in the EEPROM test function, if the key is switch 1, I'm calling EEPROM write function by passing 0x00 as an argument and count. So whatever is the count, that gets returned into the address 0x00. Similarly, if key is equal to switch 2, I'm calling EEPROM read function by passing 0x00. So whatever is stored in 0x00, that is collected to a variable called count. Else, if count is equal to switch 3 and count plus plus is equal to 9, I'm going to assign count back to 0. So if key is equal to switch 3, I have to perform count plus plus. After I perform count plus plus, if it is equal to 0, I'm assigning it back to 0. And count is been returned back from the EEPROM test function. I collect it into the count and the same logic. Whatever is the count, I want to display it on the SSD. The same logic is being used to display it. Now observe the output. I'm going to build this project. So meanwhile, let me go to the path. Under template code, I have EEPROM.x. So the build is not build is successful now, and loading is also completed. So internal EEPROM, distribute, default, production. Here is the hex file. Initially, you can see SSD is displaying 0000. I press switch 3, the count is incremented to 1. I press switch 3 again, count is incremented to 2. Now if I press switch 1, what happens? If I press switch 1, what happens? If I press switch 1, what is happening? Count is returned to the EEPROM in the address 0x00. When I press switch 1, count value, which is 2, is returned into the EEPROM in the address 0x00. Now again I press switch 3, count is incremented. So whenever I press switch 3, count is incremented. Now count is 6. Assume I press switch 2. So when I press switch 2, whatever is returned in the EEPROM gets stored to the variable called count. So I wrote 2 into the EEPROM address 0x00. So when I press switch 2, whatever was count stored in the EEPROM gets assigned to the count here. So count is taking 2 here. Are you able to follow this? So I'm trying to store some data into the EEPROM. Whenever I press switch 1, okay, so remember, whenever switch 1 is pressed, data gets returned to the EEPROM. When switch 2 is pressed, data is read from the EEPROM. When switch 3 is pressed, count is incremented. So that is how you write into the EEPROM with the help of the built-in function. Is that clear? Okay. So this completes another peripheral, which is EEPROM. So the next we have got to study is digital keypad. Okay. So digital keypad we will discuss. Sorry, not digital keypad. I'm very sorry. It's CLCD. So CLCD is left, matrix keypad is left, and ADC is left. The 3 peripherals are left. We will be continuing from tomorrow. Okay. So you do have class tomorrow, so don't miss. Okay, fine. So that is it about the EEPROM, and I hope the class is all clear. So the next peripheral is CLCD. We will be discussing it in tomorrow's class. All right, so that is it. Please have your attendance mark before quitting the session. You do have class tomorrow. We'll continue tomorrow. So, 1 second. Okay, so here is your QR. Please have it marked. Thanks for attending the session. We'll continue with CLCD in the next class. So after CLCD, matrix keypad and ADC, we will start with communication protocols. Okay, fine. Thank you all. We'll continue in the next class.